Alright, we're going to look at those three trig proofs that we saw on Friday. And I thought to start, we put all the formulas from the formula sheet that we're going to need over on the right side. First of all, you got definitions at the top. Then you've got your Pythagorean identities. And lastly, there's the double angle identities. So we're going to make use of a bunch of these throughout. Alright, so first question. You have to kind of decide which side is more complicated. They look pretty similar, and we see something going on with conjugates there. So I'm going to choose to do the left-hand side, multiply through by the conjugate of the denominator, which is cosecant plus 1. When I do that, I sort of create a difference of squares on the bottom. So if I had FOILed the denominator, I'd end up with cosecant squared minus 1. Now, this is a less commonly used identity, but if we look over to the side, we see that there's a relationship with cotangent squared. So we can actually replace that denominator with cotangent squared. And I realize I just missed a bit of the screen over there in the blue writing, but we can see that it is cotangent squared. What do we have? Cosecant minus 1. What happens then is that we can cancel out the cotangents, and you're left with what you had on the right side. So cosecant squared plus 1 over cotangent x. Alright, so number 2. You have to decide which is more complicated. Even though there's some conjugate stuff going on the left, I would say the right-hand side looks a little bit more complicated because it's got a bracket, it's got a square, and it has a reciprocal function. So I'm going to use the right-hand side, and I'm going to rewrite these things in terms of sine and cos. So looking at our definitions, we see that secant is actually 1 over cos, and tan is actually sine over cos. So I piece those together. They have a common denominator. I can bring them together as one fraction, which allows me to flip, because remember, when you're dividing by a fraction, you're actually multiplying by the reciprocal. So now I've got cos squared over 1 minus sine squared. Now, if I look over to my left-hand side, I can see that I'm supposed to have a 1 plus sign on the top. I'm not supposed to have any coses. So that means I probably want to use another Pythagorean identity to get rid of that cosine squared. I want to replace it with 1 minus sine squared. Always keep an eye on the goal, on the other side of the equation. Think, where am I trying to get to? So because we had 1 plus sine over 1 minus sine, we knew we had to get rid of cosine. So this is starting to look a little bit more like what's on the left-hand side. On the bottom there, I have just expanded it out, 1 minus sine, 1 minus sine. And on the top, I've used a difference of squares. Right, so recall the type of factoring when you have 1 minus sine squared, that's the same thing. It's like a squared minus b squared. It gives you a plus b, a minus b. So now we can start to cancel some things out. I can cancel out 1 minus sine x because there's 1 on the top and there's 1 on the bottom. So that's basically anything divided by itself makes 1. And now I'm left with 1 plus sine over 1 minus sine. And I am at my left-hand side. So I proved that it equals the other side. Alright, and now we're on to the third one. And this one is a little more complicated. Definitely the right-hand side looks more challenging. It's got a double angle, and it's got some squares and negative signs. So let's rewrite it a little bit. First of all, we'll use the double angle identity. So instead of having sine 2x, we want to have 2 sine x cos x. And on the bottom, I'm just going to write it in a different order so that it's 2 cos minus 2 cos squared. It's a little easier to factor when we put the negative second. So first thing I want to do is notice that the denominator has a greatest common factor of 2 cos x. So if I factor that out, I'm going to be left with a 1 minus cos x, and I can cancel out a whole bunch of stuff, the 2's and the cos x on the top and bottom. So now I'm starting to look a little bit more like the left-hand side, but I can see that there's a conjugate of my current denominator in the numerator of where I'm trying to get to. So usually when that's the case, we need to multiply by the conjugate of the denominator, which in this case is 1 plus cos x. And that should work out well because it's going to give us the numerator that we're supposed to have. So times by 1 plus cos x over 1 plus cos x. And what that does is on the bottom we've created a difference of squares again. 1 minus cos squared. And there's one that we've used before. That's a Pythagorean identity. 1 minus cos squared actually is sine squared. So once again, you can just replace that. It's kind of the opposite of what we did last time. That means we're going to be able to cancel out the signs. So we're going to be sine will be gone on the top, and one of the signs on the bottom is gone, and now we're left with 1 plus cos over sine x, which is what our left-hand side was to begin with.